Okay, I set up a little experiment to show you here. This right here is aluminum and copper. This is galvanized in copper. Okay, so let's take a reading on the aluminum and the copper. So 390 millivolts between those two. Now this only has a barrier of felt and that gel between it. So this is from dissimilar metals. You're getting 380 millivolts just from the difference between those two types of metals. Now let's look at galvanized and copper. So you can see that's almost double from the aluminum, just the difference in the metal. So 700 millivolts versus 350 millivolts or so. So roughly half just from the materials there. Now this gel is making 700 and something. Let's say 776. Okay. Now this is this moisturizer versus that moisturizer. It's slightly different. So 750 millivolts, 75. I actually had this reading 800 a little bit ago, so there it goes. This is was 800 and this was 700, so there's a slight difference between these two materials. So something in this moisturizer is reacting negatively to the migration of the charge from one plate to the other. Not much difference, but when you take that small difference and you multiply that across multiple plates and multiple cells, it adds up. So what we're trying to do here is effectively make the perfect cell with less money. And I wanted to show you this. This is the new cell design. Basically, that felt I had to, let me pull it apart here, sew it in a pouch to get it to keep from leaking the current out. So the cell that you see there, let's take a reading on it. Now I haven't got anything but the galvanized plate against the little pouch I created that has the activated carbon and the copper plate in it. So let's take a look at it and see what we're getting from it. So there you go. Now the difference between these two is the copper plate has activated carbon in the gel sealed in that little pouch. So the activated carbon now is accounting for 300 millivolts difference between the two. Now we have to work on what needs to be on the surface of the galvanized plate to continue to bring it up. And I actually did some experiments and I recorded them. I'll probably put it on this tape as well. But what I'm going to do here is show you how I made this cell, and we'll look at how it goes together compared to the one I posted, it's probably a couple weeks ago now, and we'll take a look at that. Okay, this is what the cell is going to look like. I have a plate and I've soldered the plate, split the wires and soldered on both sides because this is just circuit board, double-sided copper clad circuit board. And I've cleaned the circuit board and I soldered half the wires on one side and half the wires on the other side so that the whole plate is involved in the process. Then this gets saturated with aloe and then we put the activated carbon in here, and then this gets sewn together, and that's really the trick here. That helps immensely with this problem of leakage out of the side and the materials touching, and this is the solution I come up with. Now I did use super glue and super glue this edge together, and that did work, but it removed so much of the interior of the small cell that it wasn't feasible on the small size to do that. Now if I did that on a full-size battery, I would just super glue, clamp that together and super glue it together, and then I could put the whole thing, the whole pouch together that way. But that's really where the cell is right now. I'm going to build this cell and I'll test it for you. But this is basically the structure we're looking at right here. Galvanized copper clad with a wire soldered to it and some felt, a couple dollars worth of skin gel, and a little bit of activated carbon. Now the graphene caused it to raise, and I think it's going to cause it to store more, but it's not a requirement to build this type of battery. You could build it where you're just putting activated carbon and gel on the negative as well, like we were doing before. So I'm probably going to build this first one. I'm going to build it without any graphene, so I have a baseline to compare against. So this first cell here, we're not going to include the graphene. Now, I've got a very limited amount of graphene anyway right now, and I'm still looking for an acid, one of the acids I need. I found the sulfuric acid, and the other acid I need to make the graphene I haven't found yet. So that's where I'm at on that. Okay, what I did here is I sewed the activated carbon, I spread it on the inside of this, I saturated this, and then I just sewed it up in a little pouch like this. That's pretty good. I think I'm going to do some more experiments with the graphene, but because this works like this, this is the cell we're building. The activated carbon is only on the positive lead, and it's sewn inside of the bag, so there's no activated carbon outside of the bag.